time of war, you've got possibility of high-altitude nuclear detonation. Our strategic communication links could be severely impacted for hours or days. You want to know that your strategic link in a time of war is going to be reliable. And our job at Welkin Sciences is to provide a test set that allows the warfighter to test and verify their equipment will work in these kinds of threat environments. There's several impacts from a high-altitude nuclear burst, which is much different than a ground burst. Ground burst is the typical mushroom cloud you're used to seeing. You don't see that when it goes off into the ionosphere. It has a totally different effect. So it's usually not a destructive effect as far as ground resources or people. It's more an electronic effect. And the first is the electromagnetic pulse, which a lot of people heard about, an EMP attack. That kind of short circuits a lot of our electronics and our electrical grid almost instantaneously. And then there's the scintillation effect, which can go on for hours or days. The ionosphere is disturbed and our communication links don't work. Scintillation is basically a disturbance, if you will, in the ionosphere. And that does occur naturally from solar effects. It's very similar to the northern lights. Scintillation we're talking about is not typically visible, but it's happening in the ionosphere. So it does occur naturally. Typically it's not strong enough to severely impact our communications, whereas a nuclear event is orders of magnitude stronger than what we see occurring naturally.
Fading channel simulators in general are intended to emulate the ionospheric disturbances caused by high-altitude nuclear weapons effects, presumably that would result from an EMP attack. The idea is to create a received signal that has all the same distortion and disruption built into it that would be on an actual signal from an antenna. The signal created by this MILSATCOM atmospheric scintillation simulator, MASS, creates a signal that would be received by an antenna from a RF wavefront that had gone through a disturbed ionosphere. And we connect that signal to an actual receiver and see how that receiver's performance has been degraded by the ionospheric scintillation.
Our primary customer is the Department of Defense. The ones that so far have been the most interested are the Air Force, Missile Defense, and the Defense Threat Reduction Agency. We also have delivered systems to Raytheon, Lincoln Labs. Anyone who's involved with these strategic links is potentially one of our customers. We're the only company in the country right now that builds these, and they are available to the Air Force today. This is something that a company our size doesn't have the resources to invest its own R&D in, and it's only through the Air Force SBIR program that we can have the funding to tackle a program this large. We've received 2 commercialization readiness program funding opportunities, one through the Army and one through the Air Force. With the CRP program, there is funding set aside to go beyond what a phase 1 or phase 2 can do, and a lot of times that's the key component of getting that additional funding to finish off a project.
Our technical point of contact at Arnold Air Force Base, our TPOC, was very engaged in the program. He makes sure that all the assets were put into place so we could do our developmental testing. We had access to the advanced THF terminals early so we could debug the interfaces. Helped us in putting together all the assets we needed to do the initial interface testing with the receivers under test.
Our satellites have to operate through any condition. That could be, in this case, scintillation, which is either natural or unnatural. Our battlefield commanders need to be able to send messages. And without MASS, they cannot test the ability to send those messages through several operationally relevant environments. The Air Force used this for the initial operational test and evaluation of an on-orbit satellite in 2014. It continues to be available for future tests as these technologies are constantly under development. There are new communication protocols, new terminals, and new satellites, and they all need to operate through these environments, which MASS will test. The return on investment and the cost savings for the Air Force are huge. These satellites and their terminals are very large dollar value programs, and we need to ensure they work. If they do not work, then the taxpayers have wasted all that money. Thus, the ability to test them properly to perform their mission through the operationally relevant environment is hugely important financially to the taxpayers. We consider MASS to be a technology transition success. Multiple other agencies, both within the government and private companies, have purchased their own versions of this technology. They can be used for commercial satellites, just as they can be used for military satellites to conduct tests of them to operate through operationally relevant environments too. Previously, we have interacted with Welkin Sciences on MASS, but they are a highly capable company with electrical engineering and signal processing and several other fields of expertise. We desire to enhance our relationship with them and use them on other SBIR contracts. MASS is currently listed as one of our test assets, and we would like to use it to support other customer tests in the future.
The SBIR program has definitely been the reason we even exist, that as a company, or that this technology and this program are available to the Air Force today.